Okay guys, we are live. So hello everyone, I am Harshal and in this video we'll be starting with the binary search tree. So what is binary search tree? We have covered that in the last video, in the video which we have covered trees concept. So please watch that. And by the way, the title of this video is Operation in BST Part 1. This is Part 1. And if you see right now, you can see that in the title it's written Part 2. So it's actually Part 1. Okay, so this is Part 1, and we'll be first understanding what is a binary search tree. Then we'll be knowing how can we create a binary search tree in JavaScript. Then we'll be doing some operation like insert operation, and then we'll be knowing about traversal in a binary search tree. Okay, so these three concepts will be covered today, and in part 2 of this video, that means the official part 2, which will be live tomorrow, it will contain the second part, that means other operations like in binary search tree we have breadth first search, depth first search. So today we'll be covering depth first search, and in the next video we'll be covering breadth first search. So this is a traversal technique, and we'll also be covering other operation like delete operation. Okay, so I hope you have watched last video of the trees, and now we'll be starting with BST. So trees is a very basic concept, you can watch that. But about BST, BST is binary search tree. It simply means that a single node can have at most two childs. Okay, so let me explain you with the help of an article provided by Geeks4Geeks. Okay, before moving on, in the live chat, you can see that we have a course provided by Geeks4Geeks, and you can also check the description for that. So if you click on that link, it actually takes you to this page. All right. So it takes you to this page. So this is a very great course, and it's a paid course by Geeks4Geeks. So you can check out this one, and it's for data structures and algorithms using JavaScript. You can see that all of the concepts which are covered here, and it will take you from basics to advanced level. So it's a great course. If you want to purchase it, then definitely you can. All right. So now I actually wanted to show you an article provided by Geeks4Geeks. So you need to just search for BST, and you need to search for BST, and you will find an article for BST by Geeks4Geeks. So here you can see that it's actually telling us about a few concepts about BST. So you can see that they have given an example. So this is a very great example how a BST looks like. So here you can see that 8 is a node. Okay, parent node, root node actually. 8 is the root node, and then 3 is a child, 10 is a child. Then 3 becomes parent. Now 1 is a child and 6 is a child. So you can see that here we have parents and childs just like a tree, and a node can actually have at most two childs. You can see a node has at most two childs. This node 14 has one child 13. It does not have second child, but it's valid. It's definitely valid. But if a node has three childs, it's not valid in binary search tree case. All right, so I hope you are clear with the concept of binary search tree. It simply means that any node, if I talk about 8, it can have at most two child. Any node, if I talk about 3, it can have at most two child, that is 1 and 6. Or if any node does not have any child, it's valid. If any node has at one child, that means 14 has one child, it's still valid. Okay, so I hope now we can continue. And one more thing which you need to know in binary search tree is, you can see that suppose we have a starting number as 8. So suppose the user gave input 3. So 3 will be lesser than 8, right? So 3 will be on the left side. Then after this, user gave input 10. So you can see 10 comes after 8. So you can see that 10 is here. Okay, again after 8, after 3, user gave input 6. So you can say that you can say that we will first see that the root has child or not. If the root has child, okay, if root has child 3, now we will see that this child, that is now it became parent, has any other child or not. So you can see in our case, in the first case, it does not have any child. Now we'll see that the next input which we gave 6 is lesser than 3 or not. So if it's lesser than 3, then it will be on the left side. If it's greater than 3, then it will be on the right side. Okay, so that's how things work. So you can actually go through this article to get more about BST, and they have also provided source code which is available, and you can see that they have actually provided, first of all they have created a node, then they have provided insert operation, then we have provided in order traversal, and then they have just given some inputs. Okay, so you can check out these articles, they are very great. And I think in some cases JavaScript code is not available. Don't worry about that, I'll explain everything. But yeah, you can go through these if you want to learn it in your method. So I hope now we can continue. So first of all, what I'll do is I'll draw a simple BST so that you get a better understanding of BST, and then we'll continue to the coding part. Okay, so for that, what we'll do is we'll open up whiteboard. Okay, all right. So now what we'll do is, first of all, I'll just make it a better formatted view. Okay, so format background and let's give it black. Now it's fine. Okay, now it's fine. So now we can draw over it. And first, let's take an example. Okay, so first we'll be taking an example. So for starting, what we'll do is we'll take an example of a simple uh, tree which has values 12, 7, 5, 9, 17. Okay, all right. Okay, so first of all, suppose we have a tree. Okay, suppose suppose the user first of all gave input as 12. So what I'll do is I'll just write inputs. Okay, inputs, and let's start with 12. Suppose the user first gave an input 12. So what will happen is, first of all, a tree will be created. Okay, then 12 will actually become the root. Okay, 12 will become the root. Okay, so I think that we have something enhance shape also. Okay, so now let's try again. Okay, things must be beautiful, that's why. Okay, so now what I'll do is I'll be just creating again it. Okay, so 12, and then yeah, circle. Okay, so first of all it became our root, so let me just name it as root. Okay, I hope my handwriting is clear. And then suppose the user gave an input as, 7. So now tell me one thing, is 7 lesser than 12 or greater than 12? If 7 is lesser than 12, then it will be on the left side. If 7 is greater than 12, then it will be on the right side. Okay, so for this, we'll be creating an insert operation which will check if it's greater than the parent or not. So as you can see, first of all, we need to check that the parent has any child or not. Since the parent does not have any child, then we can simply insert things. Okay, if 12 had any other child, then we need to look up for that also. Okay, so now let's see. Suppose if I go here, okay, so you can see that 7 is actually lesser, so that's why we are assigning it here. Okay, so you can see now it's here. Now suppose the user gave another input. Suppose the user gave input as 9. Okay, suppose the user gave input as 9, or for now let's skip this. Right now, suppose the user gave input as something greater than 12. Let's suppose we have 17. Okay, so we have 17 here. So what I'll do is since 17 is greater than 12, so we'll be creating another line here, and now this time I'll be writing 17 here. Okay, 17. So here you can see that first 7 came up, then 17 came up. Okay, now what do we need to do is, after this you can see that, yeah, we have three values here. Now suppose after this user gave input of 9. Okay, 9. Suppose the user gave input of 9. So you can see first it will be compared to the root. Okay, so now you can see since it's lesser than 12, it will be on left side. Now you can see that since the left side has a child, you can see we have a child, that means we have a subtree. Now we need to compare it with this. You can see it does not have any child, so it's easy for us. So now you can see that 7 is actually lesser than 9. It's actually lesser than 9. So what will happen is 9 will actually come here. Okay, 9 will actually come here. So what I'll do is I'll write 9 here. Okay, so that's how actually tree works. So suppose after this the user gave input 5. Okay, suppose the user gave input 5. So what will happen is we'll be comparing it with 12 first. Since it's lesser than 12, it will be on left side, so left subtree is available. Now we'll compare it with the left subtree, that means 7. Since 7 actually has only one child, okay, and that is the right child, so we'll just see that if it's greater than 7, then we need to compare it with the right child. If it's lesser than 7, that means 5 is lesser than 7, then we'll just write it as it is. Okay, we'll just write it as it is. That's easy. Okay, so that's how actually things work in a binary search tree. That's how actually things are inserted in binary search tree. Okay, then there are traversal techniques which we'll be using to actually traverse each value. There are actually two types of traversal: breadth first search and depth first search. So breadth first search simply means we'll be starting from the top. Depth first search will be simply means that we'll be starting from the bottom. Okay, as the name suggests. Okay, so we'll see these techniques and I'll let you know which one works in which way. Okay, so today we'll be obviously covering depth first search because it has some more complications and you need to know that. Okay, so now what we'll do is we'll be writing our coding part. All right, so now what can we do is, first of all, let's open VS Code. So this was a folder. So what I'll do is I'll be simply creating a new folder, and I'll simply write BST 1. Okay, so that I know that it's part 1. So by the way, I'll repeat again, if you see on the title that the title is BST part 2, it's not BST part 2, it's BST part 1. Okay, by mistakenly they have written part 2. All right, so now what I'll do is I'll just open it here with VS Code. Okay, so let's create a file named as script1.js. Okay, so here first of all we need to create a very basic binary tree, then we'll be writing some operations inside it. Okay, so the prerequisite of learning binary tree is some knowledge about previous data structures which we have covered on this playlist. So if I take you to the playlist, just a minute. So you just need to visit our Geeks for Geeks practice channel, that in the playlist section you will find that we have a playlist here. Okay, so you can simply visit this playlist and you can see that we have covered these much videos, so you can watch these videos, so you get an overview what are these data structures and what are actually the requirements, so it gets a better flow. Okay, and one more thing, basic knowledge of JavaScript with object-oriented programming is a must for learning different kind of complex data structures in JavaScript. Okay, so please learn OOPS also if you don't know. But yeah, today we'll be using basics of OOPS. So if you don't know much, then it's still fine because basic knowledge of JavaScript is still enough. Okay, so now what I'll do is let's first create a very basic tree here. Okay. Alright, so for that, first of all, I'll say that we have a very basic tree, and for that we need to create a class. Okay, so it will be our tree class, which will actually help us create a tree instance. So let's name it as BST tree. Okay, so now inside this we'll be declaring all the methods which we'll be using, like insert operation, uh, and something like this. And then we'll be performing some operations with these functions which we'll be creating inside this, okay, methods which we'll be creating inside this. So now what I'll do is, first of all, if you initialize a tree, what will happen first? Okay, so things which will happen first is actually the root will be empty first. Okay, initially the whenever you create a tree, root will be empty. Okay, root will be empty. You will fill your first value in the root, that is 12 will be filled in the root. Okay, right? That's why. So first of all, in initializing any tree, first of all, you need to make sure that you have a root and it will be null. Okay, that's it. So you can say that this tree dot root is null. That simply means that current tree which we are talking about has a root value as null. That's it. Okay, very easy. Now we need to check that, suppose we are just initializing a tree. We are just we will be considering two cases here. Okay, so just a minute. All right, so we'll be actually having two cases here. Suppose the first case is suppose we don't have any tree. That means root equals null. Okay, root is null. Then what will happen is, if I just gave first input as 12, it will be simply passed to the root. Okay, that means root equals 12. Okay, so now comes the second case. Suppose root has a value. Suppose the root has a value of suppose 20. Okay, it had initial value of 20. That means you have already performed one operation. Okay, that means the first one. Now what will happen to the second input? Second input will actually be inserted either in the left child or right child of 20. Okay, so that's what we are actually talking about. If the root is null, we'll directly insert 12. If the root is not null, we'll simply check for the left and right childs. Okay, so now we'll go back to our code. Here what we'll say is, we'll first of all see that if the tree is empty, that means if the root is null or not. Okay, so I'll simply say that to check that, we'll be simply creating a very basic function. Okay, by the way, oops is a very easy concept, so you just need to know things. Okay, that means first the constructor is called. That means whenever you create a tree, these things which are written inside a constructor will be initialized. Okay, that means the root will be declared as null. This will be the first thing happening to your tree whenever you declare it. Okay, when you are declaring it, not performing any operation on it. Okay, whenever you declare it, this will happen one time. Okay, for one time for any tree. Okay, then now we are checking that if this dot root equals null, this will become true. Okay, it will return true, else it will return false. So we'll know that if tree is not empty, that means one value is already there, root won't be empty. Okay, if root does not have any value, it will be empty, tree will be empty. Okay, so it works like that. So now what we'll do is, we'll be actually checking how things work. Okay, so what I'll do is, I'll simply see, first of all I'll declare a tree, so I'll just name it as my tree. Okay, and you simply need to declare it as an new BST tree. Okay, that means we have created a very basic first tree which is having a null root. Okay, that means this will return true. Okay, so now let's work. So I'll just say console.log, and to access the function inside that, you can simply say my tree dot is tree empty. Okay, so very easy. Okay, so now obviously it will return true because we haven't inserted any value. Okay, so it will check that root has any value or not. No, it does not have any value, it's null, so it will be true. Okay, so now if I try to run this in the terminal, so here you can see that we have true. Okay, we have true. So I think that this is fine, and this is a very basic tree which we have created. It's an empty tree which we have created. All right, so now what do we need to do is, we actually need to create a node. Okay, what is a node? Again, go back here. So node actually means, if I talk about a node, Node simply means that suppose your tree already has value of suppose 12. Okay, it already has value of 12. Okay, this is a node, right? A node has two childs in this case. Okay, two childs in this case, so can have at max two childs. Okay, initially they will be null. Okay, initially they will be null. Okay, so whenever you are creating a node, any node, so if I talk about some other node, suppose 12, and then suppose we had 7, so 12 is the parent. Okay, suppose just ignore this above one. If I talk about this node 7, whenever I pass 7 inside this tree, 7 will become a node. 7 will become a node, and it will have two empty childs. Two empty childs. Okay, null, null. Okay, suppose 12 does not have the second child, so its second child will be null. Okay, I hope you got it. So whenever a value comes in, it will take the place of null. Okay, and it will become a node, and then it will have two different childs. Okay, that is null and null. Okay, so I hope you got the logic. Similarly, we'll be creating a node class which will be reflecting the same. Okay, so for that we can simply say that we have a class, and let's say that its name is node. Okay, so initially we'll be calling a constructor. Okay, whenever a node is created, we will be calling a constructor. Okay, so we'll just say that a constructor is called, and what will happen is we have suppose provided some value. Okay, suppose the value is variable data. Okay, that means suppose the value is, in this case you can see that the value is 7. Suppose we have provided data as 7, data equals 7. Okay, so data equals 7 will come up in this node. Okay, now what do we need to do is we can simply say that simply just assign the value of that node. Okay, we'll just call it data. Okay, we'll just call it data, and it will become 7. Okay, that means this is actually our node and we are calling it data. We'll say that it has value 7 which we have given input, and then we'll say its left will be null, its right will be null. Okay, its left will be null and right will be null initially whenever you are creating a node. Okay, so left will be null and right will be null. So I hope you got a clear understanding what is actually a node here, and how many childs it's having, left and right. That means two childs, that's a BST, and it's having null childs. Okay, initially they will be null. Later on we will be performing insert operations on each node, like whatever is the condition, then the null will be changed to some specific different values. Okay, all right, so now we have created a very basic node. Then comes our second task. So now what we'll do is we have checked whether a tree is empty or not. It gave us true, right? It gave us true. But now we are going to insert values inside this. We haven't inserted any values. So for inserting values, we will be creating an insert operation. Okay, insert function inside this. Okay, inside the BST, we will be creating an insert function. So I'll simply say whatever will be the value, okay, will come up inside this. Suppose I want to insert 7. So 7 will come up inside this, right? So suppose for the first case, I am inserting 12. Okay, I am inserting 12. You can see for the first case, I am inserting 12. It will check that whether I have a root or not. I don't have any root initially. Okay, my tree is empty. That means root value is null. So what will happen is 12 will take place of root. Okay, so now what will happen is we are going to check that if root is null or not. So I'll just say we'll be creating a new node. Okay, so that's why we created a new node class there. Okay, so new node, and we'll just say that we'll be providing the value which we have inserted. That means 12 will be created as a node. Okay, 12 will be created as a node, and it will have left as null, right as null. Okay, now what I'll do is I need to check that if the tree is empty, that means root does not have any value. Okay, so what I'll do is I'll simply say that if this dot is tree empty returns true. Okay, if it returns true, then simply assign the new node as my root. Okay, because it's the first input. You can see it does not, we don't have anything before 12. Okay, suppose initially your tree was null, now 12 came up, 12 will take the place of root. Okay, so now we'll come up here and we'll simply say this dot root equals new node. That's it. So we created a node of 12. Okay, then we have created it as a root, we have assigned it as a root. Okay, this is only for the first case, that means when the tree is empty. Now when the tree is not empty, that means we have at least one value, that is 12, that is our root. Suppose after this we gave an input 7. Okay, so we need to assign it either on the left side or on the right side, right? So for that we'll say that if tree is not empty, that means it already has some root. Okay, so I'll just say in the else case we have some root. Okay, we have some root. So for that I'll simply say that we'll be calling another method named as insert node. Okay, we'll just create a method insert node. Okay, inside this, first of all, I'll pass two parameters, node and new node. We'll see that. So here you can simply say that here we'll be using this. Okay, so what actually I mean is I'm actually passing the parent. Okay, in the first case it will be root, and the second value which I have given, okay, that means it will have value 12, it will have value 7. Okay, it will have value 12, it will have value 7. All right, so I'll just draw a tree here so that it's better for us to understand what tree I am talking about. I'll just draw a tree here, or I'll just draw a tree here. Okay, so tree diagram. Okay, so here what I'll do is I'll be drawing a tree diagram here. Okay, 12, then actually I have the diagram, so I'll just copy paste it here. Okay, so this is our tree diagram. Okay, so you can see first the input is 12, then it was 7, so it was on the left side, then it was 17, then it was on the right side. I'm just assuming that it might be the input format. The input format can be any. Okay, but yeah, 12 will be the first because since it's the root one. So 12, 7, 17, and then after 7 you have, suppose you have given 9, so 9 will be on the right side, 5 will be on the left side. Okay, so now in the first case what will happen is if the first input is 12, it will become root. Okay, now in the second case what will happen is you have already given the root element, that is 12. Now you have given the second input, that is 7. So what will happen is root will be provided to this function. Okay, root will be provided to this function, and also the new node, that is 7, will be provided here. Okay, so what will happen is we need to call it. Okay, we need to call it, we haven't called it yet, we have just declared it here. Okay, so for that we'll simply say this dot insert node, and here you just need to provide the root. Okay, that means the parent, and then the new child which you are trying to add. Okay, so what will happen is inside this we are actually deciding that either 7 will be on left side of 12. Okay, of 12, or 7 will be on right side of 12. Here we'll be deciding that. Okay, so here what will happen is we'll see that if this root is greater than this new node, that means we are going in the left side. If this root is lesser than the input, that means we are going on the right side. Okay, that means suppose if I gave input as 7, so we'll be going on the left side. Okay, I'm not passing value inside this, I'm just going on the left side. Okay, just mark my words. If value is less, you will be going on the left side. If value is greater, you will be going on the right side. Okay, so for 17 you will be going on the right side, for 7 you will be going on the left side. So now what we'll do is we'll simply say that if new node dot data is less than parent. Okay, I'm talking about parent dot data. Okay, parent's data, then something will happen, else something else will happen. So this is actually what this is actually simply means, if 7 is less than 12, then we are actually going on the left side. Okay, else we are going on the right side. Finish. Okay, so this is the first step which we are going to take while inserting This is very important because it will be helpful in further operation. That's why I am repeating things. So left side and right side. Okay, this will be suppose for first case, that is 7. It will be for suppose 17. Okay, if the input is 17, you will be going on the right side. If the input is 7, you will be going on the left side. Okay, now inside this we need to check that if 12 has any childs or not. We need to check that. Suppose if I gave you an example, uh let's copy this. Okay, let's copy this. And for example, initially, let's suppose initially 12 does not have any child. 12 does not have any child. Then what will happen? We'll check. We'll check. Actually, it must be inside this. Okay, so we'll say first of all 12 won't be having any child. Okay, 12 won't be having any child. So we'll simply insert 7 on the left side. Okay, so this will be our actually first case. So what will happen is, if node dot left equals null, that means if the parent has no element on the left side, parent has no element, that means on the left side will be null, right side on it will be null. Okay, for this case left side will be null, right side will be null. Okay, so suppose the left side is null, because since 7 is lesser than 12, we are actually opting for left side. That's why we have written node.left equals null. Okay, we don't need to check for right side for this case. Okay, only for left side we are checking for left side now. Okay, so here I'll say that if it's null, that means I don't have any value on the left side, so I'll simply assign the node dot left. That means my parent will be have left as 7. Okay, so now what will happen is, I'll just copy this again, and here I'll simply say my parent will be having left as 7. Okay, left has 7. All right, now suppose in some other case, if I talk about some other case, what can be the possibility? If 12 has left child, already has left child. Okay, so that means 12 already has left child. You can see in this case 12 already has left child. Okay, then what must happen is, we actually need to compare. Suppose the user gave input as 9. Okay, suppose the user gave input as 9, then we need to check that, yeah, here 9 is here. So then we need to check, actually not 9, we are actually for looking for the left case, so we'll be talking about 5. Suppose the user gave input 5 here. Okay, 5 here. Then what will happen is, we are on the left side, okay, for the 5, for 5, okay, for 5 we'll simply say that 5 is actually lesser than 12, that means we are on 7. Okay, again, since 12 has a left child, this will be the case. If 12 does not have a left child, this will be the case. Okay, now inside this we need to actually perform recursion. Okay, we need to actually perform recursion. So how will we perform we'll be performing recursion is simply, we'll say, again call this dot insert node. Okay, now what will happen is, now initially this was our node. Okay, this was our node, 12 was our node. Now what will happen is, we'll make 7 as our node. How it will happen is, we'll be again calling this function recursively. Inside this we'll simply say that whatever is in the left, that means whatever is in the left of my parent, that means parent is 12, whatever is in the left, that means 7, will now become a parent. Okay, again we'll do the same thing. Okay, again we'll do the same thing, comparison with the new node. Okay, now we'll simply check if it's lesser than 7 or greater than 7. Since it's lesser than 7, again it will be called. Okay, again it will be called, and here you can see that again now 7 will be here, and suppose 5 will be here. So again it will check, is it on the left side or it will be on the right side. So obviously it will be on the left side. So now you'll say that since 7 did not have any child, then this operation will be performed directly, and next time you will simply insert 5 here. Okay, you will simply insert 5 here. Okay, so I hope you are getting it. And similarly, suppose if this wasn't the case, if you didn't give 5 here, Suppose if you gave input as 9, that means right side will be followed. So now we'll be covering the right side so that you get a better understanding. In the right side, what will happen is, you can see, first we simply said that if the left child is null. Similarly, you will be simply saying if the right child is null. Okay, suppose you gave input as 17. Okay, since 17 is actually greater than 12, okay, 17 is actually greater than 12. Okay, that means we are looking for the right side. Okay, so what will happen is, we'll check that if the right child is null or not. That means if the right child of 12 is null, if the right child of 12 is null, so suppose you can say that, okay, so if right child, you can simply say that you don't need to check for the left child. Left child can be anything. You don't need to check for left child. You are actually talking about right child. Okay, you need to check that if right child equals null or not. If it's null, right child is null, then you can simply insert. Value, your value. Okay, that is, you can simply insert 17 directly. Okay, in this case we have inserted 7 on the left side directly. Here what we'll do is, we'll be simply inserting 17 on the right side directly. Okay, so again we'll simply say node dot right will become new node, same as that. Okay, we'll same as that. So it will simply mean that right side will become 17. Right side will become 17. Now suppose again we have a second case. That means, we if I talk about this, you can say that initially 12 did not have any right child. That's why we have inserted right. We have inserted on the right. Okay, we are not talking about the left. This is the right case. So we are talking about the right side. So you can see that initially 12 did not have any right child, so we simply inserted it on the right. Okay, if 12 had any right child, that means if it was already there, 17 was already there, and let's take some other input. If I talk about some other input like 14. Okay, so if I talk about 14, okay, so what will happen is, it simply means that, suppose if I already have a right child, that is 17, then what I'll do is, I'll simply make this as my parent. Initially this was the parent, 12 was the parent. Now I'll make this the parent. In the left case we made the 7 as the parent. Now what I'll do is, I'll make 17 as the parent. Okay, I'll make 17 as the parent. So what I'll do is, I'll simply say this dot insert node, and I'll make the right one as the parent. Okay, and then whatever is the new node, that means whatever is the value which you are comparing. Suppose I gave input 14. Okay, so I gave input 14. The initial node will be 12. Okay, new node will be 14. Okay, if I talk about initially 12, 14. Now suppose we have already reached till here. That means we have already have a right child. But since 14 is greater than 12, we need to go for the right side only. Okay, so now what I'll do is, I'll simply make 17 as the parent. I'll check that 17 has a left side or right side or not. So again this will be called 17, and 14 will be here. Again this will be called, okay, node will now become 17 and new node will become 14. Again this comparison will be done and things will happen that way. Okay, so I try to explain this as much as possible, but you need to check this code properly so that you get a better idea, because recursion is something you need to observe carefully and you need to perform it again and again, and this code can be actually complex. So please search it, please watch this code, please watch this video again so you get a better idea, and also watch the whiteboard material which I told you so that you get a better understanding. Okay, so now what I'll do is, I'll insert elements. Okay, I'll insert elements. Hello, I have a doubt. Pre-recorded hai kya? No, actually it's not pre-recorded. I didn't saw your chats. So Harsh, if you have any doubt, you can ask me on the live chat. All right, so now we have created the insert here. Okay, not this one. We have created the insert method here. Okay, so now we'll be inserting some values. Okay, so suppose the initially tree was empty. Now if I insert some value, obviously the tree won't be empty. Suppose if I insert the first value, again to check, we'll simply call this again. Okay, so initially it was true, tree was empty. Now it won't be empty. So let's run this again, and here you will see that first the tree was empty, now it wasn't empty because 12 became the root. 12 became the root. Okay, similarly if you add more elements, suppose after this you added 7, then you added 17, then you added 5, then you added 9. Okay, I'm actually trying to create this tree. Okay, so I'll simply paste it here. Okay, so here you can see that first I inserted 12, then 7, then 17, then 5 and 9, something like this. Okay, so you can see that we have inserted values like this. So for each insert operation, you can see first it checked that is the tree empty or not. If it was empty, the first value will become the root, that is 12. Then it will come to the second case, it will check that already root is there, that means 12 is there. So now left and right will be checked this way. Left and right will be checked this way. All right, so I hope you got this. Now we need to simply first run this. Okay, let's run this. So you can see it's giving us false. That simply means that the tree has values. Okay, it's not empty. All right, so now the tree has some values. What do we need to do is we'll perform search operation now. Okay, we'll perform search operation. So suppose I want to search an element if it's available on tree or not. So how can I do that? I'll simply say, first of all, I'll just close it. Okay, I'll be performing search operation, so you can write it as it is here. Okay, so you'll say that we have a search operation here, and we'll just say we'll provide the root element, it's important, and then we'll be providing the data. Okay, we'll be providing the data, whatever element you are searching for. Okay, so first you need the root element. I'll check that if the root is null, that means you don't have anything on the tree. Okay, so you'll simply say that if root equals null, that means your tree is actually empty. That means this element won't be available, any element won't be available. Okay, you won't be looking into any other further details. Okay, so if the root is not available, root of the tree, that means 12 is not available, that means the tree is empty. That means we'll simply return false. That means the element which you are looking for, it's not available. Now you already have some tree. Okay, you have already have some tree like this. You have already created a tree like this by insert operation, right? So now suppose I want to search for 9. Okay, suppose I want to search for 9. So what will happen is, up here you will say that suppose in the first case, very best case, okay, best case, what will be what, suppose I want to search for 12. 12 will be the root element, right? 12 will be the root element, so we'll simply return as true. Okay, so we'll simply say that if my first element is actually equal to the root. Okay, so I'll simply say root data, root data. Okay, root data is actually equal to data. Suppose if I am trying to search for 12 and my root element equals to 12, that means it's available, right? So I'll simply return true, return true. That's it. Okay, now if it does not equal, if it's not equal to 12, that means it must be somewhere around their child. Okay, so their child can be something like their childs are actually, you can see that their childs are 7 and 17. Okay, so suppose if I talk about 7, if I want to search 7, okay, if I search 7, so it will first come here, 12 and 7 will be compared. Okay, so tree, since tree is not null, this will be the case. Now 12 is not equal to 7. Okay, so this won't be the case, the next case will be followed. So here we'll simply say that if 12 is greater than 7 and 12 is lesser than 7, case will be followed. That means we either will be going the left side or we'll be going on the right side. Okay, so we'll say that if whatever is the root, that means 12 is greater than 7. Okay, so we'll be actually searching on the left side, else we'll be searching on the right side. Okay, so we'll simply say search on left side. Okay, search on right side. Okay, so I hope you got it. Now what I'll do is I'll simply make the left side as the root element. Okay, so now I'll pass the left side of 12, whatever the left side is, and the search element which you are trying to search for. So I'll simply say that the left side return, we'll be calling this actually recursively. So I'll simply say this dot search. Inside this you'll simply say that the left side will now become your root. That means 7 will become your root, and 7 is the search term. Similarly, if I talk about the right side will become your root, and right side, sorry, 7 is your search term. Okay, so now suppose you are searching for 7, okay, searching for 7. First there will be 12, 7. Okay, now you said that the tree is not empty, so this will be the case. Now 12 is not equal to 7, so we'll jump to the next case. Since 12 is lesser than 7, sorry, 12 is greater than 7, you'll simply say that 7, you'll simply say that the left child of 12 and 7 will be here. Left child of 12 is what? Left child of 12 is 7. Okay, and 7 will be there. Again, this will be called, we'll come up here. Okay, again the tree is not empty, root is not empty. Okay, so we'll again go here and we'll say that if my value, my root is equal to data or not. Yeah, in this case it's equal because now the root is 7 and we were searching for 7, so we'll simply return true, and it works like that. Okay, similarly is for the right case, and similarly for the more subtrees which you will create. Okay, so I hope you are clear with this, and now we'll be performing a search operation. Okay, so for that we can simply say all right, so here we can simply say that we'll be performing a search operation here. Okay, so I'll say that console.log, and suppose I want to search for an element. Suppose I want to search for I have passed 7 here, right? So I want to search for, suppose I'll first for search for 12. Okay, so here you'll see that my tree dot search. Okay, inside this you need to first pass the root, my tree dot root. Okay, and then you can pass the value 7. Okay, 7, so it must return either true or either false. Okay, so I think I'll just comment these out. Okay, so I've inserted values. Now I'm checking if 7 exists or not. So you can see that 7 exists. Okay, if I talk about 12, 12 is the root element, it exists. Okay, if I talk about suppose 13, if I check here, you can see that now I am getting false. Okay, so now the search operation is actually working perfectly, and it's working fine. Now after this we have performed the search operation, right? Then that simply means that our element is available. Okay, if I talk about 1, you'll see that if it's false. Okay, so now search operation is also covered, insert operation is also performed. Now we'll be performing some traversal techniques. So traversal simply means visiting each element of the tree, visiting each element of the tree for some purpose, for performing some operation like addition, subtraction to each element and something like that. Okay, or just comparing values or to do something actually. Okay, so traversal simply means visiting each value of the tree to perform something. Okay, to perform something. So there are two types of traversal techniques, that is depth first search and breadth first search. So depth first search simply means you will go from bottom to top. Okay, you'll go from bottom to top. Okay, and breadth first search simply means you'll go from bottom, then second line, then third line, and so on to in the breadth first search you'll go from top, second line, third line, it works like that. Okay, and in the depth first search you go to the depth first. Okay, depth, then go to the above one, then something like that. Okay, so we'll see depth first search today and then breadth first search in the next video. So for depth first search, it has three techniques: pre-order traversal, in-order traversal, post-order traversal. So we'll be looking into all these one by one. Okay, so let's close this search operation, and here what I'll do is I am talking about pre-order traversal. So in pre-order traversal, we'll be just drawing a diagram here. So as you can see, this was the tree, right? This was the tree, right? So in pre-order, we'll simply visit the First of all, the top one will be printed. Okay, first of all, top one will be printed. That means we'll go from top. Then we will be actually going to the second side. Okay, second side. That means we are going to the depth. Okay, we are going to the depth, in depth first search. Okay, that means this is actually for DFS. Pre-order is for DFS. So we'll go from first depth. Okay, that means we'll go to 7 now. Okay, so now we'll be going to 7. Then we'll be going to next child, that is 5. Okay, now the depth is ended. So what I'll do is, since I am in now 5, what I'll do is I'll simply jump to the next child. Okay, simply go to the next child. That means now I am in 9. Okay, now I am in 9. This 7 was covered, this 12 was covered actually. Okay, so now what I'll do is I'll simply go from here to the next side. Okay, next side the same things will be happening, and you can consider it as a subtree also. Okay, so now you can see that after this 17 will be here. Okay, so this is actually pre-order traversal. We are actually traversing each element in pre-order. Then we have post order. Okay, so we have post order. So in post order, what things will actually change is, so I'll just remove it. So in post order, what will actually happen is, I'll just make it right. So in post order, we'll simply go to the bottommost child. Okay, we'll simply go to the bottommost child. Okay, so from 5 we'll be actually going to the, you can say, sibling. Okay, we'll be actually going to the sibling. So from 5, first 5 will be covered. Okay, first 5 will be covered, then 9 will be covered. Okay, then we'll go to the above parent. Okay, above parent, then 7 will be covered, 17 will be covered, then we'll be going to the above parent. Okay, above parent is what? Above parent is 12. Okay, so you can see it works like that. So if I talk about its traversal, it simply means that first I'll go from 5 to 9 to 7 to 17, and then at the end 12. Okay, so you can see it works like that. Okay, so this was actually post order. Now we have in order traversal. So I'll just remove it. So what happens in order traversal, you will be simply going from 5. Okay, again from the bottom, it will start from the bottom. You'll be simply going from 5 to 7. Okay, from 5 to 7, then from 7 to 9. Okay, that means left side parent, right side, this is covered. Then after this, all left side will be covered like this. We'll be starting from the bottom, then above whatever are the left sides will be covered like this. Then similarly from 7 I'll be going to 12. Okay, then 12 will be covered, then right side will come up here. Okay, so it works something like this. So this is actually the in order. I'll just write it there. Okay, so I'll just say that this is in order. In order, so it simply means that if I want to go from 5 to 7 to 9, okay, then I'll go from 12 to 17. So this is actually known as the in order traversal. Okay, so now we'll be covering this. So actually in the last video I explained you in brief in this pre-order, post-order and in order, so you can check out that video also. So now we'll be implementing it into our code logic. Okay, okay guys, I think it wasn't visible enough, so I'll just make it more smaller. Okay, now I hope it's visible. Okay, now I hope it's visible. So you can see that I've actually assigned it this way: 5, 7, 9, 12, 17. Okay, and this is 5, 9, 7, 17, 12. This is 12, 7, 5, 9, 17. So pre-order, post-order, in order. Alright, so now what I'll do is I'll simply create functions which actually traverse it in this way. Okay, So now we'll be creating three types, that is pre-order, in-order and post-order. So here I'll just say that we have pre-order. Okay, pre-order. So in pre-order, first you need to provide the root element. Okay, whatever is the root element, because you will be starting from somewhere, right? So I'll be starting from the root element. So root element, that is we are on 12. Okay, so now I'll just say that if the tree has values, okay, tree has values, that means it is not null, root is not null. Okay, so I'll simply traverse the tree in some way that it simply gives me, first of all, I'll just print this value. Okay, whatever is the value, I'll just print it. Okay, so obviously 12 will be printed. So I'll just run this first so that you get a better idea. Okay, so I'll just call this console.log, and you actually don't need to write it in console.log. We are fine with this directly because we have printed values. Okay, so you can see that my tree.preorder, inside this I provided my root value. That's it. Okay, so if I try to run this, so you can see my first element is actually 12. Okay, my first element is actually 12. So I think we are fine with this. Now what will happen is, I actually want to access the left side and right side also. So for pre-order, we'll be first going to the left side. So I'll just say this dot, again we'll be calling this pre-order recursively, and again I'll be calling the left side. So again the left side will be printed. Okay, so let's see. So if I just run this again, so you can see I'm getting 1275. That means the complete left side. Okay, so if I just call the right side now, so you can see that actually we are getting 1275,917. Okay, 1275,917. So it's actually like you are actually going from 12 to 7 to 5. Okay, all left side is covered, then we'll be going to the right side, it simply means that if all the left sides will be covered, okay, all the left sides will be covered, this won't be continuing any further. So now we'll be jumping to the right side of that route. Okay, we are actually jumping to the right side of that route. Now the right side is covered, no left and no right side is available, it's null. Okay, so we go back, so again this is called, the right side is called, it works like that. Okay, so we have the pre-order. Now again we'll be doing the same for post order and in order. Okay, so let's talk about in order first. So I'll say that in order, okay, inside this we'll say that we have a root element. Okay, so inside this what I'll do is I'll just say that if the root element is again not null, okay, again not null, in this case, first of all we'll be going to the left side. Okay, so we'll be going to the left side. So first of all I'll just print it. Okay, I'll just print whatever is the value, and first we'll be going to the left side. Okay, first we'll be going to the left side, then the right side. Okay, okay, fine. So let's explore this, and here what I'll do is I'll simply print my output like this. I'll just write my output so that you get a better idea. 1275,917. Okay, it works like that. Okay, fine. In the right side, what must happen is, in the right side, that means in the in order transition, what must happen is, you can see in order, I simply visit from 579. Okay, that means start from bottom, 579, 7, 12, 17. Okay, that means covering left, parent, right, left, parent, right, it works like that. Okay, so left, parent, right, it works like that. Okay, so now that's how you'll be printing things. And again, if I try to call this in order, okay, now I call in order, so what will happen is, it first, oh, sorry, I made a mistake. It was actually in order. Sorry, in order. Okay, so now you'll see the perfect answer. So you can see that we are actually calling this again recursively. And what will happen is, first the left side will be covered, then whatever is the data will be printed. Okay, then again the right side will be covered. That means 5, 7, 9, 12, 17. Okay, similarly we have the third one, that is post order. Okay, so post order simply means that covering all siblings at once. Okay, that means left side, right side, parent, left side, right side, parent, it works like that. Okay, so this is another traversal technique. So post order simply does is, I'll just copy this again and I'll paste it here, and here you'll see that we have post order. Okay, post order. So what it will do is we'll be covering the left side, then right side, that means left side, right side. Okay, so what will happen is we'll go to the extreme left first. Okay, then left side is printed. Since it does not have any child, we'll go back. Then now right side will be printed. Since it does not have a child, we'll go back. Now the value is printed. Okay, it works like that. All right, so now what we'll do is we'll try to run this post order. So now let's test it, and post order is here 5 7 9 17 12. Okay, so it works like that. So I'll just write the output here also. So its output is actually 5 7 9 12 17. Okay, 12 17, and its output is 5 9 7 17 12. Okay, I think it's fine, and you will see the difference what's actually happening here, and the same code is written here. All right, so I hope this is clear, and you need to rewatch this video if you didn't understand the concept, and still you can ask me the doubts which you have till now. And somebody has written, भैया ये तो pre-recorded है. Pre-recorded नहीं है bro. I was actually busy in writing the code, that's why I didn't give your answer. So if you have any doubt, you can still ask me right now. So before ending this video, I actually wanted to tell you that in the live chat or in the description, you will find a link of a course provided by Geeks for Geeks, that's for data structures and algorithms in JavaScript. Okay, so you can check out this course. This is a paid course, so all the things which are required are actually mentioned, and you can actually see that they will teach you from introduction to mathematics, bit magic, arrays, everything which is in DSA using JavaScript. Alright, so you can see the concepts, and you learn definitely from beginner to advanced level. Alright, okay. So guys, I'll wait for a while so that if anybody has doubts, can ask me here. Okay, so I think nobody has any doubts, so we can end this video. So if you have any doubts regarding these technologies, MongoDB, Node.js, React.js, Express, React Native, GitHub, AWS, uh, Redux, Angular, Next.js, Firebase, C++, and Python, then definitely you can ask me on your doubts on any of my videos, on the live chat, anywhere. And sometimes definitely I delay replying your comments or your messages. So please wait patiently for that, and try to ping me again as much as you can. And also you can message me on Instagram at the Harshal_3011 is my username. So you can message me there, or you can message me on LinkedIn also. All right. So that's it for today. I will see you in the next one. Till then, have a good day. Bye bye.